Okay, guys, I have Matthew is here. I'm just saying, I know you're here. I have to say it out loud. Tanya is here. Anna is not here. Christian is here. Emma's online. Daniel's here. Victor is here. I have Ruby online. Welcome, Ruby. Nicholas is not here. Francis, nope. Ringo is a no. I have Mariah, nope. Edith Hernandez is with us online. Eddie is here. Brian Martinez is not with us. Isaac is here. Giovanni is here. Mike is here. Ryan Rios is here. Ashlyn, no. Lila, no. Rihanna's here. Obed's here. Allison's here. Paige is here. Lily's here. And Samantha is online. Who sits behind you, Giovanni? Matthew, who sits in front of you? You don't know. Well, back to my chart. Hold on. No, I'm not going to get, this doesn't get any easier for me. I'm getting too old for this. Like, I think it's my brain is too slow. Okay, so I have Matthew. Oh, Brian Martinez, but he isn't, okay. He's not here. Okay, guys, so let's go, and online peeps, you can put your answers in the chat. So number 51, scientists around the world use a standardized taxonomic system. Why would scientists want to use this? And then number 38 asked, this system classifies organisms into something called individual taxa or group. If two organisms belong to the same group, they are related. Similarity, does that make sense? Oh, sorry, I'm not reading it correctly. Similarity at which of these levels indicates the closest relationship. So go ahead and hold up your answers, guys. Hold up your whiteboard answers. Hold up your answers. Let me see them. So I have just looking. Okay, I got it. All right, Michael's looking for his pen. Isaac, we're not participating today. Oh, no candy for you. Okay. Look, there's one next to you. What you got, Giovanni? All right. So, guys, I have number 1. I have a strong A, and that's correct, right? Number 1, strong A. We talked about this really important guy, why it's important. And then for number 38, I kind of had a little bit of a split. What did you put, Allison? The J, yeah. So I had a split. Most of you put J, right, which is that genus. Remember that upside down triangle? The genus was, now actually there's one more group that's more specific than the genus, and it's the what? The species, right? So using that triangle, we were able to answer that, right? So a few of you put kingdom, and I think you were just flipping it, right? So remember, kingdom is the widest, and then genus and species, right, like Homo sapien, are the smallest. All right, guys, here is the plan for today. So we have a lot going on today. We're going to work on some of our learning packet today. And then we're going to take a quick break, and then you are going to build a cladogram, right? So you're going to have an option. You can either do it online in Google, or you can do it on paper. Okay? Either way. A cladogram. You're going to find it today. It's like a little puzzle, right? It's a little puzzle. All right. So go ahead and turn your note page, your packets, and online, it's the same page. We ended on page 4, right? So page 4 and page 5 is going to give us some practice on these 7 different levels that we talked about yesterday. So just give me a second to figure this out, because you know I'm super slow, but I think I might be getting better. Okay. Not really, because this needs to be pinned, so that way you can see my pretty face. And then we need to open this. Doo-doo-doo. Okay. And then we're going to go here. I don't understand. Why is it not showing up? Do you guys remember what I did yesterday? All right, here you go. Here's your 5 minutes of nothing while Miss Lazar figures out her technology. Guys, on page 4, it says practice. Start answering these questions. See if you can answer them yourself. We're going to go over them together, but Miss Lazar needs to figure out why. Oh, geez, there's just so much. Okay. Oh, no, I definitely need video. I don't understand why the Hoover cam's not coming on. It's like it's broken. Oh, wait, I know why. That's not what I want to do. That's why, I think. All right, here we go. Let's try it again. I think because it was over there. Okay. Get out of there. Yay! See? Don't give up. Don't give up. All right, guys, so this is the page that I'm on, right? And so this is the page we left off on. I'm going to make it a little bigger just for a second, so that way we can all go over some of these and practice. If I pin that, let's go to the speaker view. All right, it's getting better, guys. We're getting better every day. Okay, so page 4 and 5. Oh, wait a second. Can my online people see this? Oh, thank you, Samantha. Thank you. All right. So, guys, first of all, you'll notice that I have 4 different animals here, and I have these really funny names that go all the way down, right? And so the first thing that you're going to do whenever you're answering questions about taxonomy or these levels is you're going to label them on the side, right? So I need to know what's a kingdom, phylum, class, order, family, genus, species, right? So if I label it over here, this is kingdom, right? Would you guys remember it was what? King, Philip, came over for good spaghetti, right? Or spam, whichever you want, right? So this is kingdom. Oh, sorry, Philip is with a P, guys. Right? It's right here. Remember we did this yesterday, right? Don't worry about domain right now. We're not going to use domains when we're talking about classifying organisms. So I have kingdom, phylum, class, order, family, genus, and species. I have these 4 butterflies up here, and they all have, these are my scientific names, right, that we talked about yesterday. So number 1 says, what is the scientific name of animal number 1? So the clue is, remember we talked about there was something called binomial nomenclature, right? And there are 2 parts to the scientific name. What are they? The first part is what? The genus. Second part is the species, right? And the genus is what? Is it capitalized? Yes. Is the species capitalized? No. And when I handwrite it, what do I have to do to it? You have to underline it. So, scientific name for animal number 1. Animal number 1, look right here, guys. Here's my genus, and here's my species. So I'm going to write Danus plexipus, right? And I'm going to underline it, even though it kind of looks like it's already underlined. Now, if I were doing this on a computer, I would italicize it, right? This is my scientific name. Let's look at B. It says, which of these animals belongs to the same phylum? So here's how I attack this problem. Look here, guys. All 4 of these are in the same kingdom, Animalia. Well, that makes sense because they're all butterflies. Remember, we get more specific as we move down. All 4 of these butterflies are also in the phylum Arthropoda. Well, that makes sense, right? Class. All 4 of these butterflies are in the class Hexapoda. Look at the order. All 4 of them have the same order. So that means they're all exactly the same or closely related up to here. Then when I get to my family, I have an outliner, right? So now looking here, these 3, animal 1, 2, and 4, are more closely related, and animal 3 is kind of the out guy. right? Because I've changed names. Oh, that didn't even answer the question. Okay. Which of these animals, belongs to the same phylum? So is it animal 1, 2, 3, or 4? All of them, right? So 1, 2, 3, and 4. They all belong to the same phylum because they all have the same name. Yes, sir. You don't have your packet? Oh, go ahead. Sorry. Here. Yeah. Guys, there's always extras here. And you can leave it in here in the classroom if you want to. Sometimes. Oh, you weren't here last time. Oh, I'm so sorry. Don't be afraid. Just yell at me, okay? Here. So we'll go back and get the rest of your notes next time, okay? But for now, we're right here. All right, everyone else have one? There'll always be extras up here, okay? So if you need an extra one, go ahead and grab it. All right, so which of these belong to the family? Now, see. Which of these animals belong to the same order? So here's my order. Again, 1, 2, 3, or 4. 1, 2, 3, and 4, because they all have the same name, right? D says, which of these animals is most distantly related? So again, the strategy I'm going to use is I'm going to look all the way down, and once I see a different name, that means these three still have a lot in common, but this is the one that spreads off onto its own tree, right, from the evolutionary branch tree. So the most distantly related is going to be animal number 3, right, because his name changes at the family. And then look at E. Daniel, which of these animals belongs to the same family? Here's my family. I don't know. 1, 2, and 4. Good. I know it's hard to see back there. Thank you. 1, 2, and 4, right? Because they have the same name. They have the same name. They're more in common, right? They share structures. They share DNA sequences. And F says, which of these two animals is the most closely related, and how do you know? So look here, guys. Here's my family. So now he's an out. And then I move down to my genus, right? And look, who has genus in common is what? Animal 1 and animal 4. So they are more closely related than animal 2 to the rest of them, right? And the reason is because they have the same what? Genus, right? So the more names they have in common, the more closely related they are, right, on the phylogenetic tree. Daniel, do you want to move up here? Are you sure? Okay. I know it's really hard. I'm trying to keep you guys far away, because so that way if you're far enough away, if anyone's infected, you don't have to. All right. Now I want you guys to practice on your own. I'm going to give you a few minutes, 2 minutes, where it says check yourself. I want you to practice on your own. Look, they've already labeled it for you here. Kingdom, phylum, class, order, family, genus, species. You have a rattlesnake, elephant, bald eagle, and a human. We are going to go over the answers together, but I want you to try first. Okie doke? Okay. Online people? Oh, Edith, thanks. Go ahead and try these. Okay, and I'm going to give you about 2 minutes. I'm going to walk around. If you have any questions, please raise your hand. Isn't this fun? It's like a little puzzle, right? I love biology. Yes. Yes. Go ahead. All right, looks like we're finishing these up. Oh, sorry, never mind. I'll give you another sheet.
What is the most specific level of classification to which all four theories belong? So they all belong to the kingdoms, same kingdom. They all belong to the same phylum. Right? So this is the most specific, meaning the smallest one, phylum. Right? Does that make sense? Yesterday, this is the broadest, and then at the top of the triangle, as we move down, it gets really specific, right? So this is the most specific, is the species. Species in a family or in an order. So this has the most, and it decreases, right? So you will find more species here than you will here. And if you go down, it decreases as you move down. Okay. I'll show you where I'll find the rest of this.
All right, guys, let's chat about these. So some of these were a little different, right? Asking us to use our famous triangle over here. So A says, what is the most specific level of classification to all four animals? Anyone? Is it kingdom or is it species? Oh, I'm not even reading this right. Oh my gosh. Okay, what did you guys think? It is the phylum. You're right. Sorry, I didn't read that correctly. Right? So the most specific that they all belong to, you're going to find the last one where they share the same name, right? They don't share the same name here. So this is the most specific. B said, which level of classification includes the most specific characteristics? Anyone? Species, right? That was the one I was thinking of. The species for all of them, right? And so again, on our little chart here, look, species. If we have 10 animals here, we have 8 here, 7, 6, 5, 4, 3, 2, and 1, right? We reduce the number of animals as we move down that taxonomy level. Would you find more species in a family or in an order? Do I find more here or here? In the order, right? And if you look at your chart, I'm going to find more here than I am here, right? Because you can see it's simply larger, right? I'm going to find more in the order. D, what is the scientific name of the elephant? So here's my elephant. Scientific name is going to be the genus in the species. Capitalized, not capitalized, and I have to underline it. So the scientific name of my elephant is Loxodonta africana, and underline. Now, E is asking us to use our names, right? So E says, which two organisms are the most closely related? Who would like to take a shot at that one? Rihanna, what did you get?
Elephant and human.
Rihanna got the elephant and who? The elephant and the human. Okay, let's see. She put elephant and human. I haven't even looked at the key. Let's see. All right, so we have these are all in common. What it says, most closely related. Same. And then, here you go. Yep, this is where we have a branch, right? So these two, the elephant and the human, still have the same name, right? So Rihanna is correct. The most closely related are the elephant and the human. Isn't that crazy, right? And really, they're both mammals, right? So they both have mammalian characteristics. So this one is, yes, the elephant and the human. F says, can you think of 2 reasons, why these might be placed in the same class? So they do have similar characteristics, right? And later on, we're going to learn about mammals. Mammals have hair. They feed their young through secretion of milk. They can regulate their own body temperature, right? So the reason they have that same class is because they share similarities, right, in characteristics in one form or another. G says, which level of classification includes only one type of organism? Anyone? It's the species again. It's the most specific and it's one type, right? There's nothing else in there. So it's kind of like our population, right? One type of species. And then H, our last one. If 2 organisms belong to the same order, to what other groups must they also belong to? So if they belong to the same order, they must also belong to what? The kingdom, phylum, and class, right? So like say, for example, these 2 belong to the same class, so they must automatically belong to the same phylum and kingdom, right? So it's anything above that level of organization. So if in the same order, they must also belong to the same kingdom, phylum, and class. Oh, I'm sorry, yes, species. Y'all, my handwriting is like so bad. Yes, species is one type of organism, and it's very specific. All right, guys, good job. So this is some practicing, right, on our notes. And so, again, we're going to go back to this, but when I pick this up, I'm going to be checking for this, right, to make sure you've done it and also for accuracy, especially if we've done it together, okay? All right, so let's move on. We won't spend much more time on notes, but I do want to talk to you about something called a phylogenetic tree and also the cladograms, okay? And so they're kind of like evolutionary maps. So I want to talk about them for a minute, and then you guys are going to build your own, okay? All right, so let Miss Lazar get set up here once again. Right now I'm going to share my screen, but I'm going to share it with the presentation instead. And you can still see over here, I'll kind of keep up, right? I'm going to go down here because we left off yesterday. Oh, we left off here, actually, right? Yep, there's your answers. Oh, they're already right there, but we've already gone over them. All right, so we left off right here. So we talked about Aristotle, right? And we talked about Linnaeus, and we talked about some older classification systems, right? Why we needed to classify. And so now, today, we're going to focus on something called phylogeny, right? This definition of phylogeny, which is how taxonomists, which are the scientists that classify organisms, consider phylogeny of an organism when attempting to classify it, right? So the definition of phylogeny is the evolutionary history, right? So we should be writing this right here. So right here, number 2. Phylogeny, you should be writing that right here. The evolutionary history of an organism. You guys, we're going to study evolution when we come back from Thanksgiving, right? So how organisms have evolved over time. Right now, we're just kind of touching on it. To show this evolutionary relationship between different types of organisms, scientists use something called phylogenetic trees, right? And this is an example of a phylogenetic tree, right? There's all different forms. They might take different shapes and forms, but at the end of the day, they're showing common ancestry, and they're showing the evolution of a particular organism, and more importantly, which characteristics organisms share in common, right? It's another way to classify and organize. And so a phylogenetic tree, oh man, look at that. Let me move that out of the way. There it is. Put it up here. A phylogenetic tree, if you can see that at the bottom, and I'll read it as well. I'll write it right up here if you can't see it, is the evolutionary relationships thought to exist among different groups of organisms, right? So it's written down here at the bottom in red, but every time I move my mouse, it covers it, right? So these phylogenetic trees, we're going to go back to these trees because the phylogenetic trees are going to be an important piece of evidence that we use for our theory of evolution. But today, we just want to focus on how do we actually interpret them, right? How do we make predictions on these phylogenetic trees? So we're going to practice, right? You'll notice the next one, we're going to do a little practice. To your right, you'll see this nice, pretty little phylogenetic tree. And it should look like this. Oh, here it is, right? So it looks like this. Now, don't be intimidated by big words, right? You know, it's really a skill. It doesn't matter if you don't know what a cnidarian is yet, or you know, what a ctenophore is, or what a protist is, right? These are actually going to be the different kingdoms and the different types of animals, and we'll study those next week. But right now, we're just focusing on the skill of the tree, okay? So we can still interpret the tree without knowing what all these big words are. So when you look at your tree guide, there's a few things to keep notice. First of all, you always start from the bottom of the tree and then you move up over time, right? So in this particular tree, the common ancestor are the protists, right? And every tree is going to show something different depending on what relationship it's looking for. As you move up the tree over time, the protist right here, at each one of, we call these little nodes, right? You'll notice this is where they branch off. And so at this little node, anytime you have a branch that branches off, that is when there is a separation and a new species has formed, right? For different reasons. Lots of different reasons. One of them is genetics and adaptations, but we'll get to that in evolution. As I continue to move up the tree, I can see I had another branch over here. And then I turned into cnidaria and the ctenophores, right? So on this particular tree, cnidaria and the ctenophores are very closely related compared to cnidaria and the sponges, right? The closer you are on the tree and the branches, the more related you are from an evolutionary perspective, okay? And then as I continued to move up over time, I had another branch here of chordatas and echinoderms, right? So vertebrates and starfish, this is us. And then I had another species branch off into roundworms and rotifers. You'll notice up here, you're probably familiar with your worms, right? Your arthropods and your mollusks. So let's look at our first question, right? So you'll see here's the first question is right here, right? It's on the thing too. It says, what is the common ancestor of all the organisms shown in this tree? And again, remember, every tree is going to be read differently. But to look for the common ancestor, I'm always going to look at the bottom, right? So the common ancestor of all of these organisms is what? My protist, right? My protist. Common ancestor. It's this question. It's B right here, right? Are the protists. The next question says, are the cnidarians, so here are my cnidarians right here. These are actually jellyfish, or sea anemone. This is a sea anemone, right, which is in the same family as the jellyfish. Are the cnidarians more closely related to the sponges or to the comb jellies, which are the ctenophores? So here's my cnidarian. Are they more closely related to the sponges or to the ctenophores? Anyone? The ctenophores, right? More closely related. So we can also make predictions on how closely related organisms are using these phylogenetic trees, right? The more close they are on the tree, the more they share in common, the more closely related they are. So our next question. So what is the closest relative to the rotifer. So here I am right here, right? Right here. What do you think the closest relative is, just based on position? Is the roundworm, right? So the roundworm is a relative of the rotifer because they are on the same major branch, and then they branched off here into two different species, right? So we can tell relatives. Who's my relative? Who's my ancestors, right? Farther down on the chart. One more. And then our next question says, what does a branch point represent? Right? So every time I branch off, these little, where it actually branches is called a node, but every time I branch off, whether it's here or here or here or here, that is the last common ancestor shared by two or more organisms, right? That's the last time they shared a common ancestor. Something happened for them to become two separate species. Yes, Eddie? Yeah, hurry up. You're going to miss important stuff. All right, we're going to skip page 7 or the modern, where it says modern taxonomy. This number 6 right here. We're going to come back to it, but I just don't think it's relative at this time. I want to finish up that's number 6. Sorry. I want to finish up number 7 right here that says cladistics. I want to read a sample one, and then I want you guys to have enough time to get started to finish up your activity. Okay? So, are you ready? Don't write this down. This is just for your knowledge right now. So guys, all of these phylogenetic trees, you're like, how do they make these? This is really strange. So this is the different pieces of evidence that they use to make these trees. Don't write it down. You don't need to know it now. But the first thing that they do, I'm going to go pretty fast here, is morphology, right? So what is the actual structure of the organism? Do they both have wings? Do they have 4 legs? What does the organism look like? They also use something called homologous structures, right? So structures that look similar, they have similar features. For example, you can see the bones here, right, of the human, cat, whale, and bat. Their bone structures are similar, but they vary based on their mode of transportation. We also use something called analogous structures, and we're going to revisit this when we talk about evolution, okay? These are ones that, again, may be similar in function, but not necessarily in structure, right? So like the wings of a butterfly versus this pigeon-looking guy. Vestigial structures. So you guys are familiar with your appendix, right? These are structures that maybe at one time they were really important, but they no longer are, right? So sharing these vestigial structures. Fossil records. We're going to spend lots of time on fossils and evolution. Cellular organization, right? So what type of structures? Again, it's all about what do we have in common, right, with these other organisms when we're classifying them. These fossils will look for similarities, physical features. And the last one, I think, is biochemical similarities. Now, we have not talked about genetics, right, or DNA, but when we do, this is going to be a huge piece of evidence that we'll focus on. How much DNA do we have in common, right? How many A, T, G, and C's? What are our similarities of our genetic makeup? Again, I don't want to spend a lot of time on here right now. I just want to introduce them. Oh, this one's actually a really cool one. We're going to study this one when we get back from Thanksgiving. Embryo similarities, right? So this is actually really cool, guys. If you look up here, these all look almost exactly the same, right? These are few embryos. And then eventually, as they begin to change over time, look, the embryos of a fish, a salamander, I think this is a chicken and a duck and a monkey and I don't know, maybe that's a human. Over time, right, they all change over time. So that's kind of neat. We'll watch a little video. Okay, here's where I am. Now I want to look at something called cladistics, right? So that's just like phylogenetic trees, except it's more modern, right? And it's not as floofy. So cladistics, again, is another way that we classify organisms, just like our phylogenetic trees, and they use features. We use features called shared derived characteristics, right? So what characteristics do these organisms have in common to establish these evolutionary relationships, right? Do all the organisms have 4 feet? Do they all have fur? How many of them have jaws? How many have 2 ears? How many have 5 fingers, right? Do they swim? Things like that. A derived characteristic, by definition, evolved only within the group that under consideration, right? So in this example up here, again, anything past jaws, anything up here, that means that all of these contain jaws, right? That's a derived characteristic. So an example might be the feathers of a bird. Birds are the only animals to have feathers, right? It's therefore assumed that feathers evolved within the bird group and they were not inherited from a distant ancestor, right? So that would be a derived characteristic. It would be a way to classify organisms. Do you have feathers? Do you not? And then shared derived characteristics provide a strong evidence of this common ancestry, right, between the organisms that share them. So we have something in common from our past that we have kept these common shared characteristics. And that leads us to our theory of evolution, right? Again, I say things 25 times just to make sure you're listening. We will investigate and study some of this evidence of evolution when we come back from Thanksgiving. All right, so let's practice really fast, and then I'll give you guys a break, and then we're going to build our own cladogram, okay? So here is a practice cladogram, and I would like for you, oh, actually, you know what? I think the next slide is going to have it. So here's an empty one, right? But you'll notice, guys, see right here, these lines? These are the derived characteristics, right, that we're going to use to build our cladogram. So if we look at the second one, I'll switch it in just a minute. Oh, wait a minute. Okay. Oh, if you're at home, or, you know, if I don't know, this is how to read them. I'm going to say the same thing, but if for some reason you want to go back and listen. Okay, here we go, guys. I would like for you to fill in your derived characteristics. So the first one is the amniotic egg, right? Or the amniotic egg. So what that means, here's where I start down at the bottom. Amphibians branched off here. The derived characteristic is the amniotic egg, right? The egg. If you had an amniotic egg, you continue to move up. The second derived characteristic was opening and skull for the muscle, right? So anyone beyond this derived characteristic has an opening in their skull for muscles. Our next one is hair. Right? So anything above here, that means the matromeres, the marsupials, and the placental mammals all have hair, right? Anything as we continue to move up. Our next one is live birth, right? So as opposed to laying eggs, I give live birth, marsupials and placental animals. And then the last thing that characterizes placental animals is that you have a placenta. Are we placental mammals, guys? Yep, we sure are. Remember earlier that elephants and humans had mammalia, that same phylum or order? This is why, right? We birth. We have placenta that feeds our young, and we have live birth, right? So these are common characteristics. Okay, so let's look at a few questions. Okay, so this one you don't have to rewrite. It said, what are the derived characteristics? So you can just put an arrow. So these are all of our derived characteristics. The egg, openings in the skull, hair, live birth, and the placenta, right? That's what we mean by that. The first question said, which group on the cladogram arose first? So from an evolutionary perspective, over time, who arose first? If I start at the bottom, the amphibians, right? Like the amphibians right here. They arose first from a historical perspective of time. My next question says, Do amphibians have an amniotic egg? So here is where, guys, here's where the amniotic egg comes in as a characteristic. Do amphibians have that? Nope, they do not. Only anything as you continue to move up, right? So they do not have an amniotic egg. My next question, do turtles, so where's my turtle friend? Here he is, here's my turtle. Do turtles have amniotic eggs? Yes, right? Anything above this. So yes, turtles have amniotic eggs. Does this make sense, guys? Right? Reading these cladograms? Oh, more questions. Oh, sorry. This one? Good? Poor Daniel. I'm moving you up to the front. I'm moving you up to the front next class. All right, let's look at our next question. I think it's, this is E, right? Question E. Which two groups on the cladogram seem to be most closely related? So let me give you a hint too, guys. Lengths of lines indicate how closely related you are. The shorter the lines that connect you, the more closely related you are. So looking at this particular cladogram, which two groups of animals have the shortest lines connecting them? So we have a marsupials and placentals. They are definitely closely related, absolutely. But there's one more, birds and dinosaurs. Does that make sense? Yeah? So they are definitely closely, but the most closest is going to be the birds and the dinosaurs. And again, that's just because look how short their lines are, right? And the lines are an indicator of how related they are. The next question, which is F on your sheet, says list the groups that have hair. So here is the hair. So anything moving up is going to have hair. So what are they going to be? This is the monotremes. Eddie, what is this? Can you see that? Marsupial? Yeah, marsupial. These words are, you will start to notice I mispronounce them all the time. They're kind of like a new language. And then, so the monotreme, the marsupial, and what is my last one right here? Matthew. What is my last one right here? Samantha. Maybe she typed it. Brian. What does that say? Christian. Placental mammals. Excellent. Thank you. Placental mammals. Right? So our monotremes. I know the words are hard, guys. You have to if you just go for it. We're not going to make fun of you. So y'all can make fun of me because I mispronounce things all the time, right? So you become more comfortable with it the more you pronounce it. So our monotremes, marsupials, and placental mammals. List the groups that give live birth to their young. So here I am right here. Live birth. Tanya, can you list those groups for me?
Marsupials and placental.
Excellent. Marsupials and the placental mammals, right? Live birth. Anything up here? The next question says, what are the derived characteristics of the monotreme? So here I am, guys, right? I'm a monotreme. I'm right here. Any of my derived characteristics are going to be above it or below it. By derived, it means I contain these characteristics. Below it, right? So the derived characteristics of the monotreme are the hair, the opening in the skull, and the amniote egg, right? Anything below it, these are the derived characteristics. That means the monotreme is going to have all of these characteristics. And our last question, which two groups have the most shared derived characteristics? There's our words again, right? So this one up here, again, the marsupials and the placental mammals have everything below it, right? All right, guys, we are going to take a 5-minute break. It is 12:35. You have 5 minutes to walk around. If you need to go to the restroom, please go one at a time. And I'm trying to think. I do have, so next week we're going to make dichotomous keys with jelly bellies, but I have extra. So if you would like a jelly belly, you may come up one at a time. In the next 5 minutes, Eddie, don't move. Actually, never mind. I'll walk around and give you one, okay? No one move. 5 minutes. You need to take a break, stretch? Yes, sir. Yes, go ahead. And then when you come after our 5 minutes, we're gonna build a cladogram. You can either log into Schoology and build it online in the Google Slides, which I'll show you where to go, or you can build it on paper. If you choose to build it on paper, I'm gonna put them right here. Okay, and the next, you're gonna grab, let's build a cladogram, and you're going to grab your cladogram features. If you choose to do it on your computer in Google Slides, which is totally fine, I'm going to show you where to find that as well, okay? When I show, so go ahead and I'll show you where to find that if you choose. Yes? Hurry up and don't talk to Matthew. Just go to the restroom. So here, I'm in taxonomy and cladistics, and let's build a cladogram. So again, if you're online, right? If you're online or you would like to use your computer in class to do it, if you open it, I'm getting super sophisticated, guys. Super sophisticated. Okay, why is this so big like that? Oh my God. Okay, so if you open it, if you're doing it, you'll click your cladogram activity, Lazard copy, and it will make your own copy for you, okay, online. So these are my online learners. You can zoom in if you can't read that super tiny print, because I can't read it either. I usually zoom into 100. You'll read the instructions. Here are your things. And then you'll actually go in and you'll type, right, your answers in there, or you'll type your answers in here, okay? So you have two options there. You want to do it, again, in class. You guys can do it on paper. Code's fine. We're going to listen to just a little music here. And then, now online people, you can stay on. I'll be walking around in just a second to help them. And then, oh geez. Okay. These schools are closing. It's like crazy. Okay. And then I'm going to walk around. If you would like a jelly belly, you may tell me. I bought excessive amounts. And if you're ready to get started, you can start reading your cladogram if you'd like. I had a glove in here. Give me. Oh, let me see. Oh yeah, I'll put that up. Well, yeah, guys, if you're gonna do it on paper, come grab it. Come grab your paper. I'm gonna wash my hands. If you'd like a few jelly bellies, I'll give them to you. Paper or online. Isaac, you doing it on paper? Or you doing it online? You what? Okay. Would you like a few? Anyone? Isaac, you don't want to? I just want my hands. Would you like some flavors? I have super extras. None of them are bad flavors. Anya, would you like them? I'll just give you a few. Ashley, would you like a few? None of them are gross. None of them are gross. Ronnie, would you like a few? Okay. Alex?
My brother did that kind of one.
My hand, I just sanitized my hand. Rihanna, would you like a few jelly bellies? Would you like a few of them? I don't know what flavors they are, but. Victor, would you like a few jelly bellies? Ryan? Okay, guys, 1 minute. Go ahead and grab your paper. You just get a few. I have to save them for the activity next week. Where are your friends go? Oh, yummy. Okay. Oh, it's 12:41. All right. So I'm going to go ahead and get you guys started, and then y'all are going to continue to move on, and I'm going to walk around and help you, okay? So let's look at the instructions together, and then I'll let you guys go free. So cladistics is one of the newest trends in modern classification of organisms. We just talked about this idea of derived characteristics, right, which are unique to a specific organism. So we are going to build our own cladogram, okay? So procedure, I'm just going to read this really quick, and then we'll let you guys go. Make careful observations of the animals in the pictures below. As you study each picture, determine if the animal has any of the characteristics that you see in the data table on slide number 4. So for you guys, it's slide number 4, which is this one, right? And for you guys, it's going to be the one on the other page. So you're going to look at all of these characteristics. If they have the characteristic, you're going to put an X in the box. If they don't have it, then you're going to put a minus. Is that what it says? Yeah. If they have the characteristic, put a plus sign. If they don't, you put a minus. Okay? And again, your characteristics, you should be able, if you're not sure, if you're like, I don't know if it has a jaw, well then Google it. Okay? Some of them are pretty obvious. But if you're not sure, like, you should be able to tell that the lamprey doesn't have a thumb, right? Things like that. Then, after you've filled it out, you're then going to count up the total number. Using our data table, we'll be able to tell what is the out group. So what is the group, like our amphibian group, right, was the group that had the least shared characteristics. And then you guys are going to draw this on your paper. If you're online, you're going to type it in, right, using these instructions, right, the ones that have the least or the most derived characteristics. So go ahead and get started. Again, I'm going to walk around, and I will come back to my online peeps as well, okay, in a second. Play a little music. And let me make sure, online people, can you guys, that's definitely not what I want. That's not what I want. Online people, can you guys get to, do you see your own copy of this document in Schoology? Oh. I have a chat, but I can't see it. Y'all, oh, thank you, Samantha. Excellent. I think someone chatted. I don't know what happened to my chat. Oh my gosh. Oh, Edith can see it. Oh, no, Ruby, you're only going to do one. So what the kids are doing in class right now, you're doing it online because you're at home. They're doing it on the paper, or they can choose. Some people are doing it online as well. Okay, so you can choose either one. All right. So remember, everything's due on Sunday, guys, but I think you should be able to finish this today so we can get ahead. And then online people, if you want to start building this, and stay on if you have any questions, I'm just going to walk around and I'll come back to here and check in with you guys. Okay? Does that sound good? All right. All right. And if you want to listen to your own music because you hate mine, I'm totally fine with that. Just make sure it's not too loud, okay? Yeah, so. Make sense? Okay. Isaac, does it make sense? Yeah? We're gonna look at these. We're gonna start putting it. Okay, so let's see. Jaws. Out of these, who has jaws? Who has a jaw? We're gonna put a plus. Here's a jaw. Jaw. Yep. Yep. So go ahead. Put pluses. Hello. What do you think? If you're not sure, look it up. If you're not sure, if you can't tell from the picture, Google it. Do fish have jaws?
Yeah.
So I just Google the answer.
If you're not sure, like, if you're not sure, do fish have jaws? Just ask, just type it into like a little search. If you can't tell from the picture. Does that make sense? Okay. So the first one is jaws. Okay, so like lamprey. Does he have a jaw? No. I don't know, guys. Do you think the lamprey has a jaw?
No.
No, and he doesn't. Yeah, it's tricky. Jaw is technically right, so that's going to be a minus, right? So I'll do the first one with you guys too if you're not sure. The trout. So here's the trout. Does trout have a jaw? Yeah. That's right. Yeah. A plus. And then what's the next one? Oh, I don't even know who he is. Caecilian. Did anybody look him up? Does he have a jaw?
The who?
It's the.
The weird fish looking thing at the bottom. But yeah, he does.
He does, yeah. Right? He has a jaw. The tortoise. Does the tortoise have a jaw?
Yes.
Yeah. So a jaw, guys, by definition, is having an upper and a lower jaw and being able to. A cat?
Yeah.
Yep, he definitely does. A gorilla.
Yeah.
Let me look him up because I think there's something called jawless fish and then fish with jaws, and it depends on the structure of the bones. Let me look up the trout one. Yes, ma'am. No. That's a great question. Let's see. Let me look up. Actually, you know what? Let me do it right here. I don't know if a trout is considered if that's officially a jaw, if it has an upper and lower bone. Let's see. Trout. Do trout have jaws? This is how I look up the answer. Okay. Best practices here. Uncutthroat trout have an upper jaw that does not extend beyond the eyes. The distinguishing characteristics in rainbow trout is the lack of teeth. That doesn't help me. They have a hooked jaw. He has a hooked jaw. So yeah, he does. He has a hooked jaw. Let's see if there's a little picture of it. Oh yeah, see? So you can see right here. Look, here's his jaw. He has a hooked jaw. What was the other one? How do you spell it? This one? Caecilian? I don't even know what that is. Is that a fish? Does anyone? This?
Yeah.
Ooh. Looks like a snake. Let's see. Let's see if he has a jaw. It doesn't. Oh! Look. This is what he looks like close up. He does have a jaw. Look at that. Look. It has an upper bone and a lower bone, so he does have a jaw. What else? Anyone? Any other ones? You'll let me know the ones. I'll look them up. That's kind of neat.
Human.
What? Eddie.
Wait, what, for the bottom, what does that mean total?
Oh, total. I think it means. Let me see. Total number of pluses. Let's see. Look at number 4. Fill in the line of the data table marked total. Count how many organisms possess each of those characteristics. For example, how many have jaws, right? For each one of those. Yes.
I believe so.
Yes, ma'am. Yes, ma'am.
Do I think good to know because they develop lungs when they get older, it says. So, I don't know. They have gills up first and then they get lungs.
Which one is that? This Cassisan person?
Yeah.
Okay, so we had a great question from Rihanna. Do they have lungs? And so she has discovered that they start with gills and then eventually they develop into lungs, right? So this is this, I don't even know how you say that.
This is the snake-like amphibian.
Snake-like amphibian. Yes. So that's a great question, Rihanna. So yes, if eventually it becomes lungs, then we're going to say that he has them. As long as we're all using the same category, right?
So this is like that.
Yes, he does. Rihanna said he has gills that eventually develop into lungs, right? Probably when he comes onto land. Oh my, I have never seen this thing before. Have you guys ever seen this? You've seen these? No, I haven't. Look, the other amphibian. It's a legless creature.
Does the tortoise have hair?
Let's see. I don't think so, but does a tortoise have hair? That is the question of the day. Does a tortoise have hair? I do not think so, but let's look at the... No, they do not have fur of any kind. They are reptiles. So that's actually a good point. So when we're classifying, reptiles do not have hair. Mammals, such as ourselves, have hair, right? Oh, upright erect posture means you walk like this. You're upright and you walk like this. So there's only one. The gorilla?
Oh yeah, sometimes gorillas.
Do you think? Let's see.
They can.
Does a gorilla
Yeah, they could walk.
walk upright?
Yeah, they can.
They normally walk on all fours, but they are capable of walking upright when needed. So what does it say? It just says walk upright? Yeah, then it does. Yeah. Doesn't say how often. Those are tricky. That one's tricky too. It's like oh, look. Look how cute he is. Oh, he's cute. Look at him. Look at him. Look at this guy. Oh my gosh, he's so cute. All right, let's go. Total it up so we can make our cladogram. Total it up. He's a fish. He's a fish. Oh, it smells so bad. Oh, do y'all want to see my favorite website ever? I haven't played it for you guys yet, but I can. Watch this.
Wait, does opposable thumbs mean just hands?
Yeah, let's look it up. An opposable thumb. I know I misspell. I do it on purpose. It eventually reads it for me. See, opposable. Yep. Opposable, right? Means you can move it. Do monkeys have opposable thumbs?
Yeah.
Mm-hmm. Let me show you my favorite website. This is my website that I used to put on. I put it on in the background. So these are live animal feeds from sanctuaries all over the world. What would you guys like to watch? Yeah. Say that again.
Oh yeah,
Oh no, but they don't walk upright.
That's what you
Mm.
really do.
Gorillas do.
But so do cats.
Well, I don't know.
You scared them by their head.
Not normally. What do we want to watch? Cat Sanctuary? I like the bears, if there's anyone in the bears. Sometimes the bears are absent. They're hiding. Oh, we can watch. Oh, the aquariums. Oh, look at the bats. That's I don't think so. I think it may have a thumb, but it's like a paw. Let's see. Cat. Does cat have a thumb, or is it just a polydactyl? They have extra toes because of a genetic mutation. I didn't know that. Do they have opposable thumbs, meaning they can move them? Some polydactyl cats, they can appear to have an opposable thumb. Jeez, it's like exceptions to the, look at this. So we're going to say no. So I think sometimes it says through a mutation they can. Oh, look here, guys, look. Oh, look, see? These little opposable thumbs, meaning it's separated and you can move it, but it's a mutation. So we're going to say no, right? We're going to say for the general population, they do not, and neither do tortoises. Oh, look how cute. That's cute. Oh, I got a question over here. Yes, Ruby. Yes, the derived characteristics, and then limbs. So limbs are like all fours, right? So these are 2 limbs, and then your legs are 2 limbs.
Oh.
Why? What does it say? What does it say? Oh, wait, let me see. It says, what does it mean by limbs means like some type of exclusion from your body, right? Either this.
Cats have opposable thumbs.
No, not normally. It shows that some of them do in a mutation, or polydactyl mutation, but not normally. Oh, let's look at the alligator swamp.
Wouldn't everything have those?
No. Some things have gills. Chat boards may not be functioning. What is it? I don't know why it's not working. It's like it's blocking my live feed for some reason. Like, look at these little guys. All right, I can't play this, so I don't know what's wrong with it. My live cams aren't playing when I open them, but sometimes you can find really good, or you can find the bears. They're like swimming, which is super fun. Oh, here's the bat. It's a bat, flying bat cam. I want to see this guy. I want to see the alligator. I don't know why it's... I guess they're having, it says, thank you for your patience. So, I guess they're having issues with their live cams. But this is kind of a fun, it's everything. They have them, it's all over the world. It's super cool. I like to do my work to them. Right, so once you've totaled them up, then number 6 says, what is the outgroup? Right, the outgroup is going to be the one with the least. Which one is it, Rihanna? Who do you have? You have the lamprey as your outgroup? Yeah. It has nothing, yeah, I agree. The lamprey, so if the so let me put it on here, right? So right here, once you've totaled all these up, the outgroup, right? The outgroup is the one that's going to have the one with the least amount of derived or no characteristics. In the outgroup, where do you think that one's going to start? Probably going to be at the bottom, right, of your cladogram, That's just like those amphibians. Remember from the other one, that the outgroup is the one that doesn't share any derived characteristics. Right? And then for even in person, you can answer these. The most common derived characteristic, right? So looking at your table, which one, the most common derived characteristic, is going to be the one that everyone has the most in common, which is going to be what? What is it? So the jaws? Yep, jaws. The most derived, right? So I'm probably going to put my outgroup, and then the first part of my cladogram is probably going to be jaws. Let me start. Actually, I can start drawing this for you guys too. So now we're going to build our cladogram. So online, you can do it here, and then I'll start building one. Well, I can actually just do it right here, right? So let's look at the instructions. It says, the most common derived characteristic is going to be placed at the bottom, right, and our outgroup. So if I'm right here, what do you think is going to go right here? What's my outgroup? Let me write it on the thing for you guys. Let me turn this off. You do need to draw it. Yep. You need to draw it if you're in person. If you're online, you just need to fill it in.
Where?
On the, right here. It's E. See E? E says to draw your cladogram.
Oh, okay.
See it? So we said the outgroup right here is the lamprey, right? So as you build, so you're going to build yours. And then we said the least, or the most common characteristic is, you said jaws, right? The jaws. So I'm going to put jaws right here. So that means anything above here is going to have jaws, right? So next, maybe let's see, what does it tell us to do next? What do you guys think goes, next determine the second most common derived characteristic, right? And then type it in the text box with the most common trait on your cladogram. Continue until all traits have been placed. So what is our next most common characteristic? Lamprey. Lamprey. Oh, sorry, I moved it. Did I move this? Oh, I did. Sorry. Let me go back and move this back. Oops. Sorry. All right. So we said this was our lamprey, right? And then this was jaws, right? And then what goes here? Where is it? Is it the C one?
Yeah.
The C one? How do I spell that?
C-A-E-C-I-L-I-A-N.
A-N. And what characteristic, what is your second most common characteristic? The lungs? Is that what everyone got? Lungs? Our friend the lung. And then who has lungs? So what is our, I would actually start doing this maybe. I don't know, how do you guys attack this?
We just do all the same at once.
All the derived characteristics? Yeah, I think that's easier too. So what's the next one? Lungs, and then the next one that has, what would be the next one that has the most in common?
Limbs.
Limbs? Allison says limbs? Brianna, limbs? Yeah, Tanya, limbs? Paige? Okay. Limbs. And then next? Hair? Is that what you guys got? Isaac, hair? Tanya? Yeah? Christian? Eddie, hair is next?
Yeah.
Yeah, okay. Hair. And then what?
Either the last, either the thumb or the posture.
Let's say, for the purposes of building a perfect cladogram, let's go back and say that gorillas do not walk upright most of the time. Does that make it easier? Yeah. Right? Let's say for the majority of the time, let's choose majority of the time. If we do that, then it makes it nice and neat, right? So if we do that, then this is what? The thumb, right? And this is walking upright. Correct? Okay, so now you guys go in and fill your organisms in, right? Based on your chart. What time is it? It's 1:05. Oh, geez. You're going to fill your organisms based on your chart, and then you're gonna turn in your papers. We're not gonna finish. We won't finish online. We won't finish all those questions either, okay? We're gonna, I want you to turn it in before you leave, because then you'll forget it. Yes?
Those different to the
Yep.
Could I just put it in my backpack?
No, because you're not gonna turn it in next time. I need it for a grade.
Oh, you can do it right now?
Well, I mean, do you wanna keep it till next time? Okay, keep it till next time. We'll finish it next time in class, okay?
Do we pretend we can do it?
No. Guys, here's your colored sheets. If you'll just leave them on the desk, okay? Leave them on the desk for the next class. So we have 5 minutes left. We got a lot accomplished today. Go ahead and, again, hold on to your sheets. We'll finish them when we first come into class, and then we'll turn those in, and then we'll move on to our 6 kingdoms. Okie doke? No, your colored sheets do not take this. Leave them right here, okay? And you guys have a fantastic day. Y'all are like my easiest group of people. So do you guys know that I'm the instructional coach, right? So that means I actually only usually teach 1 class, but I teach 2 this year. It's a long story. But y'all are my favorite time of the day. I'd much rather like be in the classroom with you guys than in meetings every day. Y'all are such good kids. I enjoy your company, kids. I know you probably don't enjoy mine as much, but it's nice to be around teenagers instead of crazy adults sometimes. Yeah, just leave your stuff on your desk and I'll walk around and spray the middle of your desk with your colored sheet. Okay, don't lose that paper. And today's Wednesday? Thursday, so we'll see you guys till Monday. Okay, so have a good, if you were in class today and I saw your work, you don't need to do the CK12. The weekly grade will be what you did last time, and I'll give you credit for the paper grade. Okay?
Oh, yeah.
Yeah, you don't need to finish this for homework. We'll finish it together in class. Okay, just make sure that your work. Okay, online. Oh, did they already leave me? Oh, they didn't. Samantha, Ruby, and Ashlyn. You guys go ahead and just submit whatever you have, right? If you have, it's actually not Doodle Sunday, so if you want to submit it by then, but just make sure that you've submitted it by then, because remember on Monday is when I go and update your weekly grades, okay? And just submit what you have right here, and then we'll go back and do these questions together in class on Monday, okay? Are there any questions? Samantha, are you good to go? Ruby? Excellent. Thank you, Samantha, Ruby, and Ashlyn. Ashlyn, I thought you were coming back. No? Ashlyn, you're not coming back? Ashlyn, you're good. Okay. Excellent. Y'all have a good weekend. I won't see you till Monday. I thought I had Ashlyn on my roster. Is it Ashlyn? No, it wasn't Ashlyn. Never mind. It was Caitlin. It's Caitlin. It's a long story. All right, guys. You guys have a good weekend. Oh, Ruby. I'm sorry. I just saw the chat. Ashlyn's sadly not coming back. Okay. Yes, Ruby. Bye, Ashlyn. Okay, Ruby, let me figure this out. All right. Ruby, did you want to come on and ask me? Or did you want to chat it? You want to chat or you want to just put it? Oh. Do we have to do the thing you showed the second one? No, don't worry about the second one. You just do the one that we did together in class today. Okay? Good? Okay, excellent. Thank you, Ruby. Are you good to go now? Okay.
See you later. Have a good weekend. End the meeting.